Hello and welcome back to our series of videos on chemistry revision. Today's video is focusing on excess and limiting reactants involved in chemical calculations. Now this is actually the second video in this series focusing on excess and limiting reactants. You may like to look at the first video where we give an introduction to how to solve problems involving excess and limiting reactants in chemical calculations. So let us do a quick revision. In order for us to solve these problems involving excess and limiting reactants, we first start off with writing a balanced chemical equation for the reaction. We write down the mole ratio of the reactants and the products, and we will always be given certain information on the reactants, and from there we can calculate the number of moles of the given substances. Okay. Step 4 is where we need to pay a little bit more attention, where we use the mole ratio to determine which is the excess and limiting reactants by comparing what we have versus what we need. Okay, and as usual, once we have determined the excess and limiting reactants, we can calculate the number of moles of the product, remembering that it is dependent on the number of moles of the limiting reactant. And once we know the number of moles of the product form, we can easily calculate the volume or the mass as required in the question. So let's see how we can use these steps to solve our next problem. Example number 2. 10 grams of calcium carbonate was added to a beaker containing 150 cm³ of hydrochloric acid of 1.0 mole concentration. Okay, so determine which is the excess, which is the limiting, and which is the excess reactant. Okay, so let's go back to the steps and take a look. The first step we have to do is write a balanced chemical equation for this reaction. So we see that this is the reaction between calcium carbonate and hydrochloric acid, and we will realize that this is an acid carbonate reaction, therefore producing salt, carbon dioxide, and water. So we know that calcium carbonate reacts with hydrochloric acid to give us calcium chloride plus carbon dioxide plus water. Okay, so once we have written the correct chemical formula, we balance the equation by writing a 2 in front of the hydrochloric acid. So step 1 is done. So now let us take a look at step 2. We write down the mole ratio of the reactants and the products. So we can see step 2 here, mole ratio. We can see that 1 mole of calcium carbonate reacts with 2 mole of hydrochloric acid to give us 1 mole of calcium chloride, 1 mole of carbon dioxide, and 1 mole of water. Okay, so we again realize that if there's no number in front of the compound or the reactant or the product, we know that there's only 1 mole there. Okay, so now let's take a look at step number 3. We calculate the number of moles of the given substance. So let's write down what was given in the first place. Okay, so we know that 10 grams of calcium carbonate was given. So we know 10 grams of calcium carbonate is given, and we are given the volume and the concentration of the acid. So we know that there's 150 cm³ of hydrochloric acid of 1.0 mole per dm³ concentration. So we know both the volume and the concentration, which means we can actually calculate the number of moles. So let's calculate moles. Okay, so let's calculate first of all for calcium carbonate. How many moles of calcium carbonate will be there? We use the formula mass over mR. Okay, and we know that there's 10 grams of calcium carbonate given, divided by the mR of calcium carbonate. We know that calcium is 40, carbon is 12, oxygen is 3 times 16 because there's 3 of oxygen. Okay, therefore this will be 10 over 100, giving us 0.1 mole of calcium carbonate. Okay, so let us now do the calculation for hydrochloric acid. How many moles of hydrochloric acid is present? We know that the traditional formula of concentration is equals to mole divided by volume. And since we know the concentration and we know the volume, we can calculate mole by multiplying concentration times volume. We know that the concentration is 1.0 and the volume is 150 cm cube, but we have to divide by 1000 because it is dm cube. Okay, we have to convert to dm cube instead of using cm cube. So we have 0.15 mole of hydrochloric acid. Okay, so now we have done step 3, which is calculating the number of moles of the given substances. We now tackle the crucial step 4, determining which is the excess and limiting reagent by comparing what we have versus what we need. Okay, so we know that the mole ratio of calcium carbonate to hydrochloric acid is 1:2. Okay, so remembering that, let's do step 4 now. We know that the mole ratio of calcium carbonate to hydrochloric acid is 1:2, as given in the mole ratio seen in step 2. Okay, so since we know that, let us now take a look at how many moles of calcium carbonate do we have. We actually have 0.1 mole of calcium carbonate. Now, if we were to react all of the 0.1 mole of calcium carbonate, how much hydrochloric acid do we need? At a ratio of 1:2, if we have 0.1 mole of calcium carbonate, we will need 0.2 mole of hydrochloric acid in order for us to react with all of the present calcium carbonate. But how much do we have? We have calculated that we have only 0.15. So we need 0.2 moles of hydrochloric acid, but we have only 0.15, which means we don't have enough acid to react with all of the calcium carbonate. So this leads us to the conclusion that therefore hydrochloric acid is the limiting reactant. Okay, and therefore calcium carbonate is the excess reactant. Okay, so we have determined which is the excess reactant. Again, I would like to show you that we can do it the other way as well. If we started off with hydrochloric acid, now we know that the mole ratio is 1:2 and that we have 0.15 mole of hydrochloric acid. Now at a ratio of 2:1, we therefore need 0.15 divided by 2 mole of calcium carbonate. Okay, and 0.15 divided by 2 will give us 0.075 mole of calcium carbonate that we need, but we have 0.1 mole of calcium carbonate, which we can find from here. We can therefore see that we still arrive at the same conclusion, that since we have more calcium carbonate than we need to react with all of the hydrochloric acid, calcium carbonate is the excess reactant and hydrochloric acid is the limiting reactant. So we have established the limiting reactant. Therefore, the limiting reactant here is hydrochloric acid and the excess reactant here is calcium carbonate. Okay. So now we have done A, let us do B. Calculate the mass of calcium chloride formed. Okay. So now that we have determined which is the excess and limiting, we remember that the number of moles of the product will depend on the number of moles of the limiting reactant. Okay. Now, since hydrochloric acid was the limiting reactant and all of the hydrochloric acid was used, we can now calculate number of moles of calcium chloride formed using this relationship. Okay. So let us now do step 5. The mole ratio of hydrochloric acid to the product of interest, calcium chloride, is, let's take a look again at the equation, 2:1. 2 moles of hydrochloric acid will react to give you 1 mole of calcium chloride. Okay, now we remember that we have calculated the number of moles of hydrochloric acid, and we remember that hydrochloric acid is also the limiting reactant, which means all of the HCl is used up in the reaction. Okay, so the ratio will be 2:1, so 0.15 mole of hydrochloric acid will produce 0.15 divided by 2, or 0.15 divided by 2 will give us 0.075 mole of calcium chloride form. Okay, so again we come back to the fact that we have to use the mole ratio to determine the amount of product form. Importantly, we remember that this is the limiting reactant, so the amount of calcium chloride form will be determined by the amount of limiting reactant in this particular case. Okay, so we now know the mole of calcium chloride form. The mole of calcium chloride form is 0.075 mole. So in order for us to find the mass of calcium chloride, we use this equation. Remember, mole is equals to mass divided by mR. So if we want to find the mass, we multiply the mole by the mR. So mole is 0.075. Okay, perhaps it might be more instructive if I were to write down the formula. So let's write down the formula here. Mass of calcium chloride will be given by mole times mR. Mole is 0.075 times mR of calcium chloride. So mR of calcium chloride, calcium is 40, chlorine is 35.5, and we multiply that by 2 because there's 2 of chlorine in calcium chloride. So this will be 0.075 times 111, giving us a mass of 8.325 grams. Okay, so we have calculated the mass of calcium chloride formed in this reaction, which is 8.325 grams. So part B is done. So we now take a look at part C and calculate the volume of gas produced from the reaction. Okay, now in order for us to determine the volume of carbon dioxide formed, we again turn back our attention to the mole ratio. The mole ratio of hydrochloric acid, which is the limiting reactant, to carbon dioxide is 2:1. So again, we use the mole ratio. Okay, mole ratio of hydrochloric acid to carbon dioxide, which is now the product of interest. The ratio is 2:1. Let us double check. We have gotten that from the step number 2 mole ratio. 2 moles of hydrochloric acid will produce 1 mole of carbon dioxide. Okay, so since we know that there was only 0.15 mole of hydrochloric acid, we know that this is 0.15 mole of hydrochloric acid will produce 0.15 divided by 2 moles of carbon dioxide, or similarly it is 0.075 mole. Okay, so we know that mole of carbon dioxide form is 0.075. Therefore, what is the volume of carbon dioxide form will be given by, if you would remember the equation of a gas, mole is equals to volume divided by 24. So we want to find the volume. We multiply the mole by 24 dm cube. So we have 0.075, or perhaps again I should write down the equation. We'll have mole times 24 dm cube. We have 0.075 mole times 24 dm cube, and we arrive at an answer of 1.8 dm cube. And that ends our question. Okay, so you can actually see that by following these steps systematically, we would be able to determine the mass or volume of any of the products, because we have already determined which is the excess and which is limiting reactant. Okay, so just follow these steps and you will not go wrong when tackling problems involving excess and limiting reactants in the chapter of chemical calculations or mole calculations. Okay, so I hope that this video has been useful to you, and again you can pause and stop and rewind at any part of the video, and relook at it again if you want to revise. Okay, so thank you for listening, and see you in the next video. Bye bye.